Welcome to the Yaka Digital Network videos. Fossil fuels are essentially stored sunlight, ancient solar energy absorbed by plants and organisms millions of years ago, and then trapped and concentrated deep underground. In Uganda, this geological history is becoming a modern economic reality as we develop the petroleum reserves located here, in the Albertine Graben. At the same time, we are developing localized, renewable energy solutions to meet the growing needs of our rural communities. Using these resources responsibly requires a technical understanding of their chemical origins, their industrial refining processes, and their atmospheric consequences. Developing a clear map of this carbon cycle provides the framework necessary to manage the transition between resource extraction and environmental protection. Fossil fuels are classified as non-renewable because their formation occurs on a geological timescale spanning millions of years. Coal originated from terrestrial plant matter in ancient swampy forests, much like the dense papyrus wetlands found across Uganda today. In contrast, petroleum and natural gas formed primarily from microscopic marine organisms like plankton that settled on the seafloor after they died. During the burial phase, thick layers of sand and silt accumulated over this organic matter, sealing it away from the air. Over millions of years, the weight of accumulating rock and sediment created immense pressure and generated significant geothermal heat from within the Earth. This heat and pressure act on a molecular level, breaking down complex biological structures into smaller, simpler units. These fragments then reform into hydrocarbons, molecules composed exclusively of carbon and hydrogen atoms. Rather than generic rock, fossil fuels are the specific, chemically concentrated result of this long-term carbon cycle. Raw crude oil is a complex mixture of thousands of different hydrocarbon molecules, making it ineffective for direct use in engines or industry. To separate these molecules into useful products, the oil must be processed through a fractionating column. The separation process is based on a simple physical principle. Different hydrocarbons have different boiling points based on their molecular size. Using these fuels creates a carbon debt. Combustion releases carbon into the atmosphere in seconds that took millions of years for the Earth to store. In complete combustion, as shown in this equation, hydrocarbons react with oxygen to produce carbon dioxide, water, and heat energy. This rapid release of carbon dioxide overwhelms the environment's ability to reabsorb it, leading to the greenhouse effect as heat is trapped in the atmosphere. In environments with limited oxygen, like congested city streets, incomplete combustion occurs, producing toxic carbon monoxide and soot particles. Furthermore, impurities in coal and crude oil release sulfur dioxide when burned. When sulfur dioxide reacts with water in the atmosphere, it forms sulfuric acid, creating acid rain that can leach essential nutrients from agricultural soils. While combustion provides high energy output, the chemical byproducts create significant costs for both local agriculture and the global climate. Comparing these energy sources highlights the fundamental difference between finite, high-pollution fossil fuels and naturally replenishing, low-emission renewables. For Uganda, this means balancing the immediate economic gains of the oil sector with the long-term necessity of renewable energy for rural electrification. Hydroelectric power is a prime example of a large-scale, zero-emission renewable source that Uganda already uses to generate massive amounts of kinetic energy. At the community level, biogas offers a way to generate energy without the need for complex industrial refineries. An anaerobic digester converts organic waste, like cow dung, into methane gas for cooking and lighting. Unlike fossil fuels, this creates a closed loop where emissions are balanced by nutrients returned to the soil, resulting in a net zero carbon impact. Fossil fuels provide the high energy density required for current industrial growth, but their finite nature and environmental cost create a clear limit. Securing our energy future requires using the output of petroleum to build the renewable systems that will eventually replace it. You can watch more videos for all classes here and get all content at www.yaka.cc.